In this video, we're going to talk about event-driven programming. We're going to talk about delegates, which is how the event-driven programming model actually works in C#. We're going to talk about what actually I mean by events. And we're going to see how we can use event-driven programming to solve the problem that we talked about last time, which is that we have a program, we have a class here that seems to have mixed up the presentation logic with the business logic. How can we fix that? So all of the programs that we have seen so far, though they have been object-oriented, some of them, have been very procedural. We might have used objects to organize our code, to encapsulate state and behavior together, and to keep some of that information private and some of it public. But all of our control flows so far have been very much we start with the main method. The main method calls a particular other method by its name, and then that calls another method by its name, and so on. And maybe we have some jumping around here and there due to exception handling or loops or something like that. But ultimately, we've got one procedure that's using another procedure that's using another procedure. Event-driven programming also uses this idea of procedures calling each other, methods calling each other. But it's a more sort of loose, decoupled way to think about it. So in an event-driven program, you have one object that is called the event subscriber, or sometimes it's called the listener or the observer or the sync. And I will probably lapse and use all of these terms at one point or another during the next couple of episodes, but I will try to stick to calling one of them the subscriber. One object is the event source, or sometimes called the sender. And the subscriber provides a method to the source. The method is called the handler. And then when the event occurs, the source says, the event has just occurred. I will now invoke the handler. And this is called raising the event. So let's take a look at an example, starting with the event source. All right, so I've started up Visual Studio here. And we've got our old friend, the Hangman class. I'm going to say that it is an event source, and that the program class will be the event subscriber. We declare an event in the source like this. So I'm going to say public. Events are almost always public. It's legal to make them protected or internal or private if you want, but there's almost no reason why you ever would. So we've got a public event. Now I'm going to explain what this event handler of char means later. This is another generic type, like we've seen before. But maybe you can guess what this means. And I'm going to call the event duplicate guess. And you can probably figure out that when a duplicate guess has been made, then some handler is going to be invoked, and the handler is going to be given the character that was the duplicate guess. So now, let's see what happens. How do we raise the event when the player actually does make a duplicate guess? So we'll scroll down a bit here into the bit of the code. We had this method guess. We check to see if the game is already in progress. And then we say, was this letter guessed already? If it was, well, here's how we raise the event. We say, if duplicate guess, remember this is the name of the event, we say if it is not null, then what we do is we call it as though it were a method. Now you'll notice there's no receiver on the method here. We've usually seen a receiver, but you know that the this reference can be omitted when you're inside a method of a particular class. So maybe this is the same as this.duplicate guess. Yeah, it looks like it is. There it is right there. All right. So we are invoking the duplicate guess event with this as the receiver. We are also passing this as an argument, and we're also passing the letter that was the duplicate as an argument. So raising the event is just like calling a method, except that for some reason we checked to see if it was null beforehand. We've never done that to a method before. That doesn't seem like it's really necessary. And we're calling this thing with the receiver as this and with this as the argument. So there's maybe something that we don't quite understand about how this works yet, but let's just let it go for now. Let's take a look at what the code in the subscriber looks like. So I'm going to go over to our little program class. Now, we still have a console application here, and it's a bit unusual to use this event-driven programming style in a console application. It's legal. It's just not that common. Usually, you would use event-driven programming in more of a graphical user interface kind of application, and we'll talk about that in the next few videos. But just for the sake of giving a simple, straightforward, clear example that we can debug easily and that we all understand, I'm going to stick with having a console application right now. So we are going to create our hangman object, as we always have before. And the way in C# that you say, I am a subscriber, and I would like a particular method to be the handler for a particular event sourced by a particular object. The way you do that is you use plus equals. And again, this seems a little bit odd. You'd think that plus equals is for adding two things together. We know that j plus equals 1 is a shorthand for I would like to increment the variable j by 1. This actually does make sense, and we'll talk about why in a little bit. But I'm going to say that the duplicate guess event gets a new handler. The handler is this method on duplicate guess, which I've made a little method up here. I've got a static void method. It takes two parameters, an object, which we'll call sender, and a character, which we'll call letter. And it says, you already guessed that letter, try again. All right, so we've got a very simple little static method. But we're not calling it. We are saying down here, this method over here that I have just named is the handler for this event. And it's a common pattern to have this on pattern where we say if the event is foo, then the handler is often on foo or some variation on that. So let's just take a look at the control flow and see if we can understand what's going on here, just from a perspective of which code calls which code. So we'll step into this thing. We'll create a new hangman object. I'm going to debug into this thing real quick because I want to know what the word is. The word is establishment. Okay, so again, I'm cheating at hangman. I'm a bad person. All right. And so now we're going to say the duplicate guess event is handled by on duplicate guess. All right. So now we'll get our outcome in progress. We'll make a guess. Read the key. This pops up. I'm going to guess E. And now let's step into our guess code here. The game is in progress. We add E to our collection of letters that have already been guessed. So there's now one thing in that. The word does contain it. We fill in our correct guess. We didn't win. Now we keep on going. All right. And if we look at the output, then it says that's correct. And in fact, this is the word establishment with just the E's in it. All right. Now I'm going to guess E again. And we'll see what happens this time. All right. So we'll step into the guess method. The character is still E. The game is still in progress. Guessed already does contain this letter. So we say, is duplicate guess equal to null? We can look at that thing. No, it's not equal to null. So we're going to take this. And now it looks like we are calling a method. Well, what method are we going to call? Let's step into it and see what happens. And sure enough, we call on duplicate guess. The sender is the hangman object, because remember, we passed in this as the first argument. The letter is the letter E, and we write out, you already guessed that letter, try again. We can take a look at our output. All right, let's stop that. All right, so what's going on here? I said before that events are implemented using something called a delegate. So I want to talk a bit about delegates. Delegates are objects whose purpose it is to call a method on your behalf. And so hence the name delegate, right? You delegate some authority to them. You say, I would like you to do this thing on my behalf. And a delegate is a special kind of type. Now, unfortunately, we use the word delegate to mean both the delegate type and a particular instance of a delegate type. And that can be very, very confusing. So I'm going to try to say delegate type when I mean the delegate type, and I'm going to try to say delegate instance when I mean an instance of that type. I may slip up, hopefully not. Delegate types are reference types. They're like classes and interfaces. In fact, delegates are a special kind of class. And every event has associated with it a specific delegate type, like event handler, or in the code that we saw, event handler of char, the generic delegate type. So what exactly do I mean by a delegate? Well, suppose I have an instance of a delegate type. Right? So remember, this is an object that has the ability to call a method on your behalf. The instance refers to a specific method, and that method may have a specific receiver. Now, of course, if the method is static, as it was in the example here, there is no receiver of a static method. The receiver is the type, right? There's no instance that is going to be the receiver of the static method. So the receiver would be null in that case. But if we had a delegate to an instance method, then it would need to also know what is the receiver of that instance method. When you call invoke on a delegate instance, that causes the runtime to execute the method that the delegate refers to as though it had been called with the specific receiver that the delegate also knows about. Right? So basically, we're saying a delegate is an object that you can say invoke on it, and it will just call some method for you. Now, C# allows you to elide the invoke. And recall, by elide, I mean you can eliminate some syntactic element, but the compiler knows that, yeah, it's supposed to be there. We'll just ignore it. This is an idea from linguistics. So let me take a look back at the code again here. We'll take a look at the place where we raise the event. Right? I could have said duplicate guess dot invoke. And in fact, you see that IntelliSense is telling me, why, yes, there is a method on here called invoke. There are a bunch more. There's begin invoke, dynamic invoke, end invoke. These are for special purpose delegate scenarios involving asynchronous delegates and things like that we're not going to look at in this course. So there's an invoke method. And if we use IntelliSense here, we can see, oh, the invoke method takes two parameters, two arguments, an object reference called sender, which is the object that is producing the event, the source, and a character. And sure enough, that's what we give it. We give it the object that is producing the event, the source, or the sender, and the character. So C# allows you to elide that invoke. You can put it in there. Almost nobody does because there's no need to. Now, I just told you a lie. It was a small lie. A delegate instance can actually refer to one or more methods, each with its own receiver. So when we invoke a delegate, if that delegate is what we call a multicast delegate, if it refers to many methods and receivers, then it will invoke all of them in turn. And how does this work? How do we make a delegate that can invoke multiple methods, each one in turn? Well, it's actually just the same way that we concatenate strings together. If you have a string hello and a string goodbye, you can say hello plus goodbye, and you get a new string, which is hello goodbye. Now, neither of those strings are changed. Right? Strings are immutable in C#, but nevertheless, we can concatenate them together with the addition operator. Well, delegates are just the same. If you have two delegates, then you may add them together with the addition operator, with plus. And when you do so, the result is neither of them are changed. Delegates are immutable, just like strings are immutable. But the result is a third delegate whose behavior is when that delegate is invoked, it will invoke each of the methods of the previous delegates in turn. And just as with strings, if you take a delegate and you add null to it, then that's essentially a no-op. You get the same delegate back out. Just as if you have two strings, one of them hello and one of them null, and you add them together, then the result is hello. All right, so now maybe it's becoming a little bit more clear how delegates and events work together. An event is kind of like a field whose type is a delegate type. The subscriber uses plus equals, and it says, hey, event, you have a handler. That handler is a delegate. I would like to add to that handler a new delegate to this particular method, and then assign the resulting new delegate to the list of handlers. So first, the existing delegate instance and the new one are combined, and then the field behind the scenes is what's assigned to. So that's why we use plus equals, because logically we are adding one delegate onto another. So to raise the event, the source invokes the delegate instance, and that then in turn invokes all of the handlers. And so now it's clear, perhaps, why we have to check to see whether the delegate is null or not. Let's go back to the code real quick here. Right. Here, we check to see, is this delegate, is this event null? Because that's how it starts. When the class is created, there is no delegate. There's no delegate assigned to this event. And so it's given the null delegate. When we add an event handler to that thing, then we have created a new delegate and assigned that to the field, what looks like a field of delegate type. And now we have something that's non-null. We have something that can be invoked. So this pattern is very, very common, where we check to see if the handler is null. If it is not null, then we invoke it. All right, so let's take a look in Visual Studio now. I've made some modifications to our Hangman class to add a bunch more events. You can see here I've made a grand total of 5 events, one for duplicate guess that we already had, and then I've added event sources for incorrect guess, correct guess, game lost, and game won. And then in our listener, I've said, all right, we're going to create our new Hangman object, and then I'm going to add 5 event handlers, one to each event. And let's take a look at what these guys do here. Right, so we have these methods on duplicate guess, on incorrect guess, and so on. And note that each of these is a private static method. And you might think, well, wait a minute. Isn't it the case that private methods cannot be invoked from outside the class? Right? This is a class program. This is a private method. How is it that the Hangman class is allowed to invoke this thing? Well, it's actually a mistake to think of the rule as a private method cannot be called from outside the class. The correct way to think about it is that this name is private. You cannot say program.onDuplicateGuess from outside the program class. You can't look up that thing by name. But there's no reason why this thing can't be called from outside if the program class itself says, I would like to make a delegate to this method. I can see its name. I'm going to make a delegate out of it. And then I'm going to hand that delegate out. Right? So again, this is why delegates are called delegates, because they allow you to say, I would like you to do something on my behalf as though I had done it. And so that's why calling private methods is allowed here. All right, so let's take a quick look at these on duplicate guess, on incorrect guess methods, and so on. On duplicate guess we've already seen. On incorrect guess is a bit interesting. Remember that we passed in the Hangman object as the sender, but it's of type object here. We need to obtain the Hangman object, and I'm just going to cast sender to the Hangman type. Now, I said in the previous video about the is and as operators that that's a dangerous thing to do, because this thing might not be of the correct type. But we have a pretty good reason to believe that this thing is going to be of the correct type. This code subscribed to the event in the Hangman class. It gave this thing as the handler. It has a reasonable expectation that the Hangman class is going to pass itself as the sender, right? That is going to be well behaved. So we can cast this thing with a fair amount of confidence that we're doing OK here. And now we can say you have Hangman dot mistakes remaining, because now we have access to the code that we now have access to the object that was the source of the event, right? This Hangman object. And so we can get properties off of it. All right, in the event that the game is lost, again, we say you lose. Oh, and by the way, the word was, because we didn't have that feature before. On correct guess is uninteresting. On game one, again, we want to say, oh, here was the word. And we can make this program a bit more friendly. We can say, welcome to Hangman, and what's your name, and create a player object and say, welcome player, set up the Hangman object with all of its event handlers. And then run through our usual game loop. One minor thing that I wanted to point out here was we can make a small improvement right here. Suppose somebody accidentally types a capital C when they intended to type a small c. Maybe they've got caps lock on. Since all of the words in our dictionary are in lowercase, we might just say here, I want to change this into the corresponding lowercase character. So I'm going to say char to lower, and then give this thing. And this will automatically turn it into a lowercase character. Now, one other quick aside. You might have seen here while I was typing, there's actually two lowers. There's to lower and to lower invariant. You might wonder what the difference is between them. To lower will use the lowercasing rules for whatever locale the computer is in right now. So if we were in Hungary, then it would use the Hungarian lowercasing rules, which are not necessarily the same as the American lowercasing rules. In fact, they're not. There's an interesting problem that would take me too long to explain called the Hungarian I problem. I encourage you to look it up on the internet. So we could say to lower here, and that would mean use the rules of the current user culture, or we could say to lower invariant, which is a special culture invariant version of to lower. All right. So figure out which one is the right one for you. Use the right one. So now let's take a look at our Hangman code and see how it has been improved. If we go down into the guess logic, all of those console.write lines have disappeared. Right? If there's a duplicate guess, what do? We say raise the duplicate guess event and bail out. If we've made an incorrect guess and it's the last one, then we say raise the game is lost event. If we've made an incorrect guess but the game was not lost, raise the incorrect guess event. If the game was won, then raise the game won event. If the guess was correct but did not win, then raise that appropriate event. So all of that logic involving how the game is actually displayed to the user has been moved totally out of this class. This class is now only responsible for maintaining the state of the game and figuring out does this sequence of guesses produce a win or a loss. Right? So it's much more like a state machine that has only one responsibility. Remember the single responsibility principle is if you needed to make a change to something, how many classes would you need to change? Well, if we wanted to change the output of this program, why should we have to change the business logic that computes whether we're winning or losing? That code should be somewhere else, and in this case, it's in the program class. So let's think about some other ways that we could have achieved this same goal. This is by far from the only way we could have achieved the goal of moving our presentation logic out of the Hangman class. We could, for instance, have created an interface. So I could have created an interface like this, right, which we'll call iHangmanDisplay. Seems like a perfectly good interface. And then it could have these 5 methods on duplicate guess and on incorrect guess and so on. And each one could take the same arguments as the event handlers. Then we could create another class called Hangman Console Display. It could implement all of these methods. And then when our program class creates a new Hangman, it could also create one of these Hangman Console displays, pass that thing in. The Hangman class could maintain a reference to the display, and every time it needed to display something, it could call one of these methods. So this would be very, very similar, right? Except that instead of having events being sort of the events and delegates as being the currency of how the two classes communicate with each other, this interface would be the way that the two classes communicate with each other. And this is a very, very common mechanism for creating this sort of callback. In fact, it's probably more common than the event-driven one. It has some pros and cons. The The event-driven solution requires that every time you're about to invoke an event, you check to see if it's null or not, and it's easy to forget and accidentally dereference null, which will crash your program. The interface solution requires that the code that is implementing the handler, in this case, the code that actually does the display, would be required to implement all those 5 methods. You're not ever required to handle an event. If there's an event that a source is producing that you don't care about, you just ignore it. You never register a handle for it. The event happens, and nobody ever finds out about it. Now, in this case, it seems unlikely that you would ever want to have an event listener that did not listen to all 5 of these events. It seems unlikely that you would say, well, yeah, I care about whether you lost, but I don't care about whether you won. So that's maybe points in favor of an interface-based solution here. One of the nice things about the event-driven solution is that you may have as many handlers as you want for a given event. So if you want to have 2 handlers, that would be perfectly fine. So for example, if we wanted to say, oh, you know what? I really only do care about the winning and losing events. And every time somebody wins or loses, I would like to register a handler and have this handler called when somebody wins or loses. Then I could say, well, I'm going to keep track of a static count of the number of games that were won and the number of games that were lost. All right, so just to review a little bit, I want to make sure that we understand what is referencing what here. So if we have our Hangman class here, and it has an event called game1, this guy you can think of logically as a field of delegate type. Delegates are reference types, and so therefore this refers to some instance. Now, suppose I have a delegate of type event handler of character. What does it have? It keeps track of 2 things. One, what is the receiver of the method call that I'm about to do? And that will be null if it's a static call, or it will be an actual reference to the receiver if it's a non-static call. And then somehow it keeps track of which method to call. So in this case, it might call the onGame1 method. Now you might ask, how is it that the delegate keeps track of which method to call? And the answer is magic. This is a type that has deep knowledge of how the runtime actually works, and it knows how to keep track of where that object is in memory and how the CLR keeps track of it and all of that stuff. All right. So I want to talk a bit about some features of events that we're not going to cover in this course, just to make sure that they're mentioned at least once. Events can be unsubscribed. We talked about how to subscribe to events. We can say minus equals, and that has the same effect as subtracting 2 delegates. So you can add 2 delegates together to get a third. You can also subtract delegates. You can say, I have a delegate that has a bunch of handlers. I would like to subtract one of the handlers from it. And again, you get back a new delegate that has one of those handlers removed. It's a lot like the immutable collections that we talked about before. Remember, these operations do not change any delegate. They return you a new delegate. Just as you can make getter and setter methods for properties, you can also make add and remove methods for events. So events are actually, they're a bit like fields, and they're also a bit like methods, just as properties are a bit like fields and properties are a bit like methods. So if there's some additional logic that you need to make happen when a new event handler is added or an event handler is removed, you can implement that code yourself. Almost nobody ever does. And events can be virtual. Events can be protected. Very, very rare. Events are almost always just straight up public, non-virtual. I also want to talk a bit about some features of delegates that we're not going to talk about much more in this course. You can declare your own delegate types. We saw that there was a delegate type called event handler of char. There are arbitrarily more delegate types. There's lots of them that are declared for you in the .NET base class libraries. There's also the ability to create your own. And functional style programming is really all about creating delegates, about passing them around, about making delegates that call other delegates, and all kinds of crazy things like that. We're going to talk not at all about functional style in this course. And finally, the rules for how can I say, well, I would like a delegate of this type to refer to that method. How do I do it? Those rules are pretty complicated, and we're not going to talk about them in this course. So, summing up, Events are for the situation where there's one object, the source, and it says, something happens, you might care about it, I'm going to tell you when it happens. And then the sync, the listener, is the code that says, oh, well, I care about when that happens. You should call this method when that happens. Events can be used to move concerns out of a class, to say, well, this class only has one responsibility, and if something of interest happens, that class can simply call another class. Let it know, hey, this thing happened, you might care about that, you go do your thing. And finally, events are implemented using delegates. Delegates are objects, and they can call a method on your behalf.